to explain that you have some opportunity to use AI and machine learning for any kind of domain. Actually, I just wanted to present my research on AI and machine learning application to cybersecurity. So I have made a research on what could I potentially do with machine learning to help me in my day-to-day job in cybersecurity. So I will share my presentation. So let's try that. Your screen is shared, okay. All right. All right, is my screen visible?
Yes, it sounds good. Yeah.
All right, at least this is working. So this is a tool I developed independently on my personal time. So why did I choose to build that? The first reason is that the Canadian Center of Cybersecurity, because I'm based in Canada, didn't have such tooling available. So one of the use cases I have decided to work on, I wanted to have something useful to give to the SOC. So the SOC is a Security Operations Center. So those are the people who are watching alert, who are on the front line when there is any kind of threat attacking the company. And for that, they need to identify the pattern of threat actors, so like ransomware or malware. And there is a little code that shared across the cybersecurity landscape. It's called TTP, which stands for Tactic, Techniques, and Procedure. And this little code is like an identifier of a technique used by a threat actor. So let's say a threat actor is encrypting file. So the encryption, it has a code. It's like a T and some letters. Screenshots, it has also another code. So all those codes, they are used across CM. CM is like a Splunk, or it's like a big database of all kind of alerts. And the SOC team make some purple teaming. So purple teaming is a concept of red team, so the attackers, and the blue team, the defenders, working together to ensure a good coverage, like to reduce the attack surface on the company. And I wanted to show that machine learning can help to anticipate the threat of tomorrow. So since it was not existing, I said, okay, like it will take a time, but maybe I can start building something that will be useful for the community. So how I have proceeded. It's a very long journey because I have done this since about a year. And I was doing a lot of research on the internet on different kind of blogs to understand how each threat actor is working. So I was like pulling a lot of resources, comparing how they describe those behavior of those ransomware and malware so that I could extract data. The first problem is to identify reliable sources, because many companies, like you have antivirus companies, they will give you a part of information, but they are not going to give you the full picture I was looking for. You have other companies who maybe study the malware, like they make some forensic, so they have another part of the data. The idea was to combine both. And then I wanted to automate stuff. So I've started coding, and I was able to parse some blog in search of those TTPs, because at the end of the day, those are the information that is useful for the SOC team to do purple teaming or red teaming. So I was doing the manual mapping, comparing different resources, and then compile all in a database. And after that, when I had a good database, I was performing what we call a frequency analysis and predictions via machine learning. So what is it? So you have a database and you want to see how many times this element and this element are together. And also how many times this element single appear across the database. So this is the type of frequency analysis. And prediction. So based on all the data I have in my database, is it possible to predict somehow what may appear in next campaigns? Because in companies, you cannot be fully protected against everything, right? It has a cost. We are maybe limited in staff, so you have to put some priority on some of them. And this is exactly the goal of my tool, is to give SOC team where to focus. So I had to decide which algorithm I will be using. So in machine learning, you have many types, and I've tested a lot. I didn't choose linear regression because the ransomware amounts fluctuate way too much. I mean, at the beginning, you could use linear regression, but after a while, like around beginning of 2000, they start to have custom ransom for companies. If you are a small company, they will ask you a tiny amount. If you are a huge company, they are going to ask you a lot of money. So you cannot really use linear regression. Logistic regression, sorry, and SVM, they are classification algorithm, which means it's like, is it a malware or is it not a malware? You know, this type of thing. You cannot classify because it's already a malware. We already know that for sure. So you cannot use this type of algorithm. The random forest. So it's like making a big spider web. But because all those threat actors, they work together, it's something that is not very exploitable. Like it will be too dense to actually see something on the screen. So it's not very easy to visualize, which is why, and it's very memory consuming. So when you try to render that, it actually frees the laptop. So I decided, no, I don't use a random forest. But if you have a good power on your laptop, maybe it's worth to try. K-means, no, it's just to cluster numerical value. I didn't have numerical values. I had text, so not numerical. I couldn't use this one. And gradient boost, it's for ranking. And there's nothing to rank in my case because they are all same level. So I didn't find the use case for that. And the Markov, you could see the Markov will be useful there, but the data is not sequenced. So that's not applicable there. But I found two good candidates. So I found the a priori and I found the Monte Carlo. Okay, just what is a priori and what is Monte Carlo? So the a priori is like a relationship algorithm. Like it finds a relationship between items across a database, for instance. So this is what I was saying earlier. Like you want to know this technique and this technique, how often do they appear together? So this is the type of thing that the a priori can do. And the Monte Carlo is actually good for making predictions. It's like launching a dice. And if you launch a dice, let's say 10,000 times, you will see some result. And if you launch 100,000 times or 1 million times, your probability are going to be more certain, let's say like that. So that's why you can use the Monte Carlo for that. So meet the dataset. So this is the type of database I have been working on. So you have like the ransomware name on the first column. Then you have the date, the first appearance, are they active, which country of origin, what platforms they are targeting, and the type of techniques they are using. So this is something like that I have built. I had, at the time of my first presentation 6 months ago, 218 map malware. So this is when I say map, I mean fully mapped. Like I have all the data on those ransomware, and I have performed frequency analysis, and I have performed prediction on that. So frequency analysis, that is what I was saying earlier. Like for technique, so the technique is identified by this little code. You can see, you can choose if you want to know the frequency analysis since the beginning of all the ransomware, or if you want to be more specific, like let's say the last 5 or 6 years, or even the last year, or even the last 2 years. You can choose that, and then it will give you a list that's going to be different. So it will tell you what is the top technique used across all those ransomware, and then that's where you can put effort. I have done the same thing for comments. So for the comments, they always delete copies on the laptop, so to erase trace. They always write something in the registry. They always use some vulnerabilities. So that's why I have done this frequency analysis on the comments as well. And then I have done a type of presentation like that to see the relationship, how often a group of certain techniques appear together. So across the dataset, I had like 44, if I read good. So I had 44 times this group of 4 techniques. So this data is like 6 months ago, but it gives the SOC where to put the priority when they do some exercise. Then I have done the same for Monte Carlo. So I have compared prediction of 10,000 with prediction of 100,000 times. And this is a result. So I have seen that this technique are the top technique always appearing for the last 2 years. So this is also something that the SOC is happy to have, so that they can focus the exercise on. Then I have built a new platform. So the new platform, I have above 500 ransomware map, and I have 87 that are absolutely active. And then I have updated my database this month, and I had 325 more. So it's recent data. Then I have a couple of agents that are actually pulling information, and they write that in the database on a regular basis. This is a database when it is updated. So you have a different color when it is a new data, whereas when it is already existing data. So I have 307 map ransomware, fully map. This is, I have all the data about the country targeted, about the domain targeted, about the technique used, about the command used, and I have been performing frequency analysis and the prediction on my application.